Alright, so let's walk through some neutralization reactions. This is my acid, and I know that because it's got lots of hydrogens to give away. This is my base, because it's got an OH group to give away. That's going to give me water and a salt. This is my salt. Obviously, this is water. The salt comes from here. We know hydrogen has a +1 charge. And then CO3, hydrogen has a positive charge, CO3 has a negative charge. +1, -2. This is a polyatomic ion. And then we've got strontium hydroxide. Strontium has a +2 charge. Hydroxide has a -1 charge. And then we've got water. So the hydrogen is going to go away to make water. The hydroxide is going to go away to make water. That leaves strontium and this carbonate. Strontium has a +2 charge, and then carbonate has a -2 charge. We don't need to do any crisscross method here. Those are already balanced. We've got enough positives to balance out our negatives. But the equation as a whole is not balanced. So let's do our inventory. We've got hydrogens. That one. Strontium. And OH. Before the equation, we have 2 hydrogens, 1 carbonate, 1 strontium, and 2 OHs. After the arrow, we've got H2O. Now there's a bunch of things you can do with H2O. Some of you that are a little bit more confused, you might want to break it up into H, OH. It's the same thing. We've still got 2 hydrogens, 1 oxygen. But that's just another way to think about it. So I've got 1 hydrogen, 1 OH after the arrow. I have 1 strontium, and I have 1 carbonate. What's out of balance here? The only thing that's out of balance is my OH and my H. And it looks like I've got twice as many before as I do after. That one's actually pretty simple, so all I have to do is add a coefficient of 2 in front of my waters. So now I have 2 H's and 2 OHs. And my equation is balanced, just like that. Let's move on to another one. Here's my acid. Once again, it's got a hydrogen to give away. Here's my base. It has OHs, hydroxide, to give away. That's going to give me water and a salt. This time I haven't identified the salt for you. So remember, this one's going to go away to make water. This one's going to go away to make water. I'm left with bromine, which has a -1 charge, and barium, which has a 2+ charge. So I know I'm going to put barium first. We always do the positive one first. And bromine, they're going to go together, BA, But remember, barium had a 2+, bromine had a 1-. This time we do have to crisscross. The positives and negatives are not equal on that compound. It wouldn't actually stick together. So I need to put this 2 right there. So my salt in this case is BaBr2. So now let's do our inventory to make it balance. So I've got hydrogens, bromines, bariums, and hydroxide. Before the equation, I had 1 of each, and then 2 hydroxides. After the equation, remember that we can break this up into H, OH. I've got 1 hydrogen, 2 bromines, 1 barium, and 1 OH. So I know that I'm going to have to do something with my OHs and something with my bromines to make it balance. Let's go over here. I know I need 2 more OHs. So the only one that has an OH in it on the after side is right here. So I'm going to have to put a 2 in front of the water. Time to update the inventory. So now I've got 2 OHs and 2 hydrogens. Go back to the other side. I'm still out of balance on the thing that contains bromine. So 2, 1, I'm going to have to multiply my amount of bromine on this side by 2. Update the inventory. Now I've got 2 bromines. I've also got 2 hydrogens. Look down the list. 2, 2, 1, 2. I'm completely balanced. So I needed 2 hydrogen bromides plus barium hydroxide. Gives me 2 molecules of water and 1 molecule of barium bromide salt. Made a typo there. Let's move on one more. Zinc hydroxide plus HCl. Zinc hydroxide, because of the OH group, we know that that's our base. HCl is our acid because it has an H to give away. It's going to give us water and a salt. Zinc has a +2 charge, -1 charge, +1, -1. So this OH is going to go off and make water. This H is going to go off and make water. That leaves me with zinc and chlorine. Zinc, 2+, chlorine, 1-. Those are not balanced. The positive-negative charges are not equal. So I need to do crisscross method. That 2 is going to go over here. So now I've got ZnCl2, zinc chloride. That's right. Now let's look at our equation and see if we're balanced. Take our inventory. I've got zinc, OH, H, and Cl. I'll just do this right away. 4, I've got 1 zinc, 2 OHs, 1 hydrogen, 1 chloride. After the arrow, I've got 1 zinc, 1 OH, 1 hydrogen, and 2 chlorides. So once again, I'm off balance. Sorry, you can't see that. Off balance in 2 places. So first thing I will do is let's mess with this chlorine one. I need to double the amount of chlorine that I had before the reaction. So I'm going to have to put a 2 up here. Perfect. So now I've got 2 chlorines, but I've also got to double my hydrogens. And then on this side, I need to do something with both OH and H. What compound has both OH and H? Our water. We just need to double it, because we had 1 after, 2 before. So we're going to put 2 in front of the water. Update my inventory. Be the same as putting a 2 right up here. So now I've got 2 H's and 2 OH's. Look down the list. I am completely balanced. 1 zinc hydroxide plus 2 hydrochloric acids gives me 2 waters and 1 zinc chloride salt.